After you collected your data, you usually want to graph it. So graphing your data basically means you put it into the coordinates. Let's quickly review what that means. So if you have the coordinates, you have your x-axis, which goes horizontally, and your y-axis, which goes perpendicular to this. Where the two axes cross, you usually have the point 0, 0. So that's the coordinate. X equals 0 and y equals 0. And so now let's just assume you have some data, x and y, and your x values would be 2, 4, and 6, and your y values would be 3, 6, and 9. Now, if you wanted to put these into this graph, you would go for your x 2 over, and then for your y 3 up, and so your point would be right here. The next point would be x equals 4, and your y equals 6, so you would put this right here, and then 6, your y value would be 9, and so then you can see that these points pretty much lay on a straight line, and you can combine them like that. From your experimental design, you probably still remember the terms independent and dependent variable. The independent variable is what you change, and that usually goes onto the x-axis. And the dependent variable is what you are measuring, and that goes onto the y-axis. So if you look at these three data sets, you would have your x here. That's the age. That's what you're looking at different time points, and you're measuring the height. That is the dependent variable that goes onto the y-axis. Same water temperature at different depth. You go, this is where you're going, x-axis, and you're measuring the temperature, and that would be on the y-axis. And this last one, you're looking at temperature over time, so this is your x-axis, and this would be on your y-axis. So after you determine what is your x and what is your y, you need to determine what kind of a graph do you use. So if you measure a continuum, which this data set here would be, because these individuals, you are looking at age at different time points, but there are time points in between, and at height. So a line graph in this case would be appropriate. So then you look at your data and you say, okay, if my x goes from 1 to 8, how do I have to determine, how do I divvy up my x-axis? So you could just put these data points right here, 1, 2, 3, 4, 5, 6, 7, 8, and that would be appropriate. Well, you can't use the same scale on your y-axis because your data points go from 75 to 121, and you would be way up on this y-axis. So you can actually interrupt your scale, and you can go from, let's say, 70 to 120, so you go 70, 80, 90, 100, 110, and 120. Now let's see what this looks like when you graph the points. Okay, if you put those points in, you could connect those at a line because this is measuring a continuum. Now you can't project out too far, and you should look at the tutorial on how to interpret your data, because as we all know, let's say this was a human and we're measuring height at different ages. At some point we stop growing, and so you have no idea how it goes on after the data points that you have. So okay, let's look at this graph. Here we have on the x-axis we have different times of the day, and on the y-axis we are measuring the number of children in a swimming pool. This is not exactly showing a continuum, because number of children increments in full numbers. So a line graph may not be a really good representation for these data. So these are similar data sets where you have a category, fruit, and you measure the number. So this would be your X and this is your Y. Here you look at different sports, which would be on the X-axis, and you look at how many individuals, let's say, are playing the sport, which you would put on the Y-axis. And in these cases, you would choose a bar graph. Let's take another look at the children in the swimming pool data set. So you have on your x-axis the time of day, and on the y-axis the number of children in the pool. We had the line graph, which we decided was not the best way to show the data. However, if you use a bar graph, it's a lot more appropriate.